So, good afternoon, everybody. My name is Shannon and I'm the head of security for Mastercoin. Mastercoin is one of many new startup companies that focus specifically on Bitcoin-related technology. They were one of the first to be fully funded by Bitcoin. They pay all their salaries in Bitcoin as well. So I've worked for them for about 8 months now, and mostly I do triage. Let's see. So here's some statistics about Bitcoin and cryptocurrency in general. There's over a $5 billion market cap right now in all of the different cryptocurrencies. There's a number of copycat currencies, and as well as some more innovative currencies that have come about since Bitcoin. Some are clones of the Bitcoin software, some are completely rewrites. Ripple was actually in the news recently for becoming one of the first cryptocurrencies to start working deals with banks. So last year, there was a vulnerability that was pretty public. It had to do with Java's secure random. An undisclosed amount of Bitcoin was stolen due to this vulnerability. It was improper implementation of this using secure random by a number of developers. One of the things that is interesting about the Bitcoin space is it's extremely rapid. The developers are working ridiculous hours. They copy a lot of code. They have very thin teams. A lot of them don't have testers on the teams. You know, it's what Silicon Valley was 10 years ago. It's kind of nuts. So this is an example of what happened. This is a transaction that was found in the blockchain. We can see the input script 1 and input script 2 have very predictable conflicts there. So somebody was able to actually take this information, reverse it, and use that secure key and get access to that Bitcoin wallet using that information. So this is an example of cross-site scripting vulnerability that somebody sent into the blockchain. It was never exploited, but it was an interesting proof of concept. So what happens with Bitcoin, and this was actually found on blockchain.info. It's an explorer that lets you browse different Bitcoin transactions. So you can see where the money came from and where it went and who sent it and how long it took to get there and all sorts of information. So what somebody did is they sent a specially crafted message to an address that, once decoded, would dump out some JavaScript onto the page. The particular page that this was discovered on was encoding their characters correctly, so this didn't actually execute. But it's a great proof of concept and sort of highlights that this kind of attack is pretty common, actually, as in web applications, but it's the first of its kind in something like the Bitcoin blockchain. So when I first got into Bitcoin, it was relatively recently. It was about 8 months ago when I started working with Mastercoin. I decided that I was going to use what's called a brain wallet. So typically, how Bitcoin works, if anybody doesn't know, is you generate a private key, and then from that you derive a public key, and from the public key you derive a Bitcoin address. And that address is where you send all of your money from and where you store all of your funds. You can have as many addresses as you want, and the way that you access the funds and the way that you send funds from the address or spend funds is by using your private key to sign a transaction. So if you don't have the private key, you can't sign a transaction. The blockchain won't accept that spend attempt. What people quickly realized is that an address and private keys, they're hard to memorize. So somebody came up with what's called a brain wallet. And a brain wallet is effectively a wallet where the private key is derived from some information that you choose, like a really long password. So they suggest using strings found in literature. So I thought, okay, cool. I'm going to use the longest password I've ever used from the only poem I've ever remembered. And the string that I derived my private key from was, I went to the woods because I wish to live deliberately. It was camel cased. I went ahead and I sent $100 worth of Bitcoin to the address. I started waiting for it, and it never got there. Well, it did. I did finally figure out what happened, and it showed up, and then within 3 seconds it was gone. So I was really hooked. I was like, okay, what happened here? Somebody stole my money. Now most people would be pretty upset. I was pretty excited. Something interesting happened, and I didn't know how. So after a bunch of digging, and I realized that what was going on is that people have made huge databases of private keys that are derived from just about every possible string that exists on the internet, and they're watching every single address. And as soon as any money gets into it, they go ahead and they pop it out into one of their accounts. I did a little bit of research on it. There's more research that I discovered recently. Some of the things that I recognized or I noticed were identifiable addresses. So I noticed 2 or 3 of the same addresses doing the same things. As an experiment, I went ahead and took a couple other strings from famous books and one from a Shakespeare play. Tried those. They were stolen from them almost immediately. So the lesson here, if you want to get into Bitcoin or any other cryptocurrency, don't use a brain wallet. So, SQL injection. Actually, that's a bad graphic. It doesn't really belong there, but everybody's familiar with the classic SQL injection car. So, one of the things that I tried while testing for Mastercoin was I was going to create an asset for Mastercoin that I'll explain what that is and how that works a little bit later. But pretty much, I push a string into the blockchain, and that's going to be the name of my asset. So I'm going to make my own coin. And the first thing I did was I see all these different string inputs, and I'm like, okay. So I go and I dump in this huge line of JavaScript that's supposed to pop just about every single cross-site scripting vulnerability that exists. Or if one exists, this string will usually do it. And then a bunch of random characters and another one, and then a string that was too long, another one. I was really trying to blow this up. And the name of my coin was exploit coin. And like most people, this idea, or like most of us in here anyway, this idea came to me at about 3 o'clock in the morning, and I pushed it in about 3:30. I wake up at about 8:30 to a whole bunch of text messages that says, "Hey, were you messing with the system last night?" Come to find out, I brought down a whole bunch of software wallets that Mastercoin uses. So a lot of the users that have their Mastercoins and their Bitcoins, they keep them in desktop wallets or wallets they keep in their on their phone, and this effectively broke it. While I was goofing around with cross-site scripting and JavaScript, it actually had inadvertently tripped up some SQL that the application was using. So that was a pretty exciting first couple of weeks at Mastercoin. And the interesting thing is that coin, it's in the blockchain. The blockchain right now is about 20 gigs long, and it's going to be there forever. So what I've inadvertently done also is that also forced anybody else creating software in the future to also have to take care of this case, because they're going to write a client and it's going to go ahead and download all the possible coins that exist, and it's going to see this transaction and it's either going to break or it's not.
Good.
So hopefully it's my little piece to offer them. Okay, I said I would cover some things in the future. Bitcoin 2.0. So Bitcoin 2.0 is a newer concept. Mastercoin was one of the first. Since then, there's been a couple others, Ripple being one of them, Counterparty being another one. But what Bitcoin 2.0 is the idea is to create another currency that lives on top of the Bitcoin blockchain using Bitcoin currency. So there's a spec that's defined that basically says if I create this type of Bitcoin transaction and I encode this particular data in my addresses that I'm sending money to, then the Mastercoin spec is going to recognize that as an asset creation, or as a coin destroyed, or as a peer-to-peer sell. So pretty much what all of the 2.0 meta coins, as they like to be called, does is they define a spec that says this is how you parse my transactions. You read these regular Bitcoin transactions, and if they match a certain sequence, then go ahead and calculate them and figure out whether they're a Mastercoin transaction, and go ahead and apply that to the overall Mastercoin consensus. What's interesting, one of the major goals of all of the 2.0 coins is to create their own currencies. And with that, they want to create their own currencies that have different features. So when sending Bitcoin, it typically takes about 10 minutes for that transaction to be solid in the blockchain. With some of the other currencies, they are building in features that isn't a requirement. One of the features that a lot of the companies are really excited about are smart contracts. So a contract between two people that does not require trust. One of the big issues that cryptocurrency is trying to solve is the issue of trust. So I don't trust the person I'm dealing with, they don't trust me. How are we going to do business? And before, there's always been an escrow involved, so there's opportunity for collusion. And so Bitcoin 2.0 and the coins written on top of that are attempting to solve that by making multi-key signature schemes and contracts that exist that say, hold on to this money until this particular time, and then if this action happens before this time, go ahead and send the money back. So you can have things like wills, you can have things like savings addresses, you can have, there's a whole bunch of things that can be created with this, including problems. Okay, so I already talked about the string fields. All of the Bitcoin 2, the Bitcoin 2.0 and metacoins have the concept of creating a currency. So when you create a currency, you're going to need to store things like the name. You're going to need to have a description and a URL to find further information. This is unavoidable, although some people have suggested taking it out of the blockchain. That kind of defeats the purpose, because outside of the blockchain, it could go away forever. Somebody can change it. That's not the idea behind cryptocurrency, is that if it's in the blockchain, it's there and it's unchangeable. So we obviously need to have input and output sanitation of all of the strings. One of the things that I should mention is that while I made that exploit coin for Mastercoin, I haven't tested it on any of the other ones. So I was thinking of titling my talk "Low-Hanging Fruit for Security Testers," because it's one of the probably least tested next to devices, wearable devices and Internet of Things devices until recently. spaces that's rapidly growing. So Bitcoin startups, Bitcoin 2.0 startups and coins, they need testers. They need good software developers. They need security, and they need it first. So speaking of Internet of Things, these are a couple of strings that, or a couple of search queries that, for Shodan, that will actually result in finding a large number of Bitcoin miners. So Bitcoin mining is a way of securing the blockchain. So when I create a transaction, I'm going to send it off into the network. And then a whole bunch of other nodes on the network are going to see that transaction, and they're going to make it real. And what that takes is what's called proof of work. And proof of work basically means that everybody that's on the network is doing this work. They're hashing. It's a SHA 256 and a SHA 256 problem. And what it shows is that there was significant hashing power at the time of the transaction to make this transaction real. And it also shows that not only was everybody in agreement, but everybody was in agreement and that they were doing work to prove that they were really there. I think I just butchered that explanation, but anyway, what this has done at the beginning, the hashing was done on CPUs. Within a number of years, as the number of people increased creating Bitcoins, oh, I forgot to mention that you create Bitcoins when you do this hashing work. So if you're lucky enough to successfully find the hash of that particular problem, then you have found what's called a block. Oh. So, and as a reward for doing all of that hashing work, the finder of the block is rewarded 50 Bitcoins. Or now it's 25 Bitcoins. They have the reward every number of years to keep the supply. I'm not sure. So, where was I going with that? Okay, so yeah, people used to mine on CPUs. As more people started making Bitcoins, they realized that they weren't fast enough, the competition was too heavy, so they started to move to GPUs because GPUs can do a lot more hashes per second. Soon, GPUs were expensive, so they developed really awesome ways of having many GPUs running, many video cards running on a motherboard. Some innovation happened where they built these mining rigs that all they require is a power supply, a motherboard, and like 10, 15 cards, video cards. So some really cool stuff happened. And then somebody came along and said, well, we can beat that. We're going to take these FPGAs and we're going to go ahead and re-implement what the GPUs are doing, but we're going to do this in FPGAs. And FPGAs are essentially, it's a piece of hardware that instead of your instruction set being written in silicon, it's a bunch of gates that you can programmatically control. So you can take this FPGA and make it do software type tasks at a hardware speed, but you program it instead of build it. So that worked for a number of years, and actually not. Probably only really was effective for a number of months.
So once the finite number of Bitcoins is given out, what's the incentive to do the proof of work?
Every transaction that happens on Bitcoin includes a miner's fee. So a small fraction of Bitcoin you send to the miners, and once all of the Bitcoins have been found, the only thing the miners will get will be the miner's fees. But the idea being that by the time all of the Bitcoins are found, they would have only been found if there were people using them. And if there's people using them, then there's enough transactions going on to justify continued mining, because they're going to reap the transaction fees and they're going to be significant enough to Realistically, though, the numbers say that it's not cost effective to mine Bitcoins. The electricity cost is crazy. And they always have to chase the prize because there's always new competition coming on, making finding a Bitcoin much more difficult. So they have to keep on innovating and keep on adding to their farm. There continue to be innovations. People have made what are called ASICs, which are just special chips that do just one problem. And then these ASICs are getting smaller and smaller and smaller, so you can cram more and more and more onto a board. Now we're down to something in the size of this can do, what do I have? So about 200 gigahash per second. Yeah, this is what we. So anyway, you can do quite a few hashes, but they're very specific, and I thought it would be really cool if we could repurpose those to do brute forcing, but unless you have a database that's full of SHA-256, SHA-256, then it's not going to do you any good. But anyway, so there's this one particular Bitcoin miner that I had, and I noticed looking at the traffic that it used an E tag in the HTTP header, and I was able to find. I thought I had it on a slide. I was able to find about 500 of those. And I was able to find about 175 of them. Another one, some percentage of those are going to have default passwords. I have a theory, although I don't own one of the machines anymore, so I haven't taken the time to acquire one and test it, but I'm pretty sure that it's going to be vulnerable to an OpenSSL bug. Speaking of OpenSSL, Shodan again let me, this isn't Shodan, this is another website, but similar to Shodan. It lets me identify all of the nodes that live on the Bitcoin peer-to-peer network. And this particular client, 9.2.1, has a known vulnerability and below. So I'd taken the screenshot right around the time that the heartbeat bug had come out. So it's vulnerable and everything below are vulnerable. I think now we've got about 40% of people that have upgraded beyond that, but that leaves the network pretty susceptible still. One of the other things that I want to mention, just doing another sort of manual test. I took a look at the actual IPs that were connecting to my particular node, and I just threw it into a web browser. Most of them have port 80 open. A lot of them belong to websites that are dealing in cryptocurrencies of some sort. They're selling currency, or they're building a wallet, or they're offering some sort of trade facilitation. This would be a really easy way to find a target, denial of service that target, extort that target. There's really no reason for you to run this particular kind of peer-to-peer node that's public-facing and that runs on the same machine as your website and a database. But these are the kind of mistakes that are more than common. They're to be expected, I'm finding. Oh yeah, here, my slides are out of order. So, attacks in the future. What can we expect to see as far as security in the blockchain? Before we talk about the future, I'd like to see the present stuff taken care of and mitigated. And that's not going to happen until testing and security testing specifically gets worked into their development cycle. But anyway. So one of the things that I've recently come across is this USB device here that's effectively a cryptographic token, and some company has repurposed it into being the authentication piece for a Bitcoin wallet. While I think that's a great idea and a step forward, is it susceptible to bad USB? Is the chip susceptible to having malware installed? If that's the case, okay, it's a pointless piece of tech. I heard about, actually there was a group today even announced, the company is called BitSim, and what they have created is they created a piggyback SIM card. It's extremely thin, and what you do is you take your SIM card in your phone and you slip it inside or on top of this little SIM. And then it takes, and it basically man in the middle's your SIM card. And it's got a cryptographic chip on it, and it's got a hardware wallet built in. And the idea is to, their idea is to take Bitcoin to another country. Specifically, they're trying to take Bitcoin to Africa. And they think that they can help the adoption if they put it in everybody's phones. Well, while I think that it's cool tech, I think that it's dangerous tech. I don't think that anybody here can think of many cases that man in the middling your SIM card in your phone is going to lead to anything but bad things.
Ebola coin. Ebola coin.
Another type of hack, this is an inadvertent hack. There is a popular coin that people might have heard of. It's just almost as popular as Bitcoin. It's called Dogecoin, and they've got a little dog as their logo. Well, they were starting to lose their value in this space. People were not as excited about the coin anymore. So this party broke off, and they created some new software. And they called it Doge Party. And they thought that it would be fun if the way that they distributed their coin was by inventing something they called proof of burn. And one of the things that happens in the space is, in the cryptocurrency space, is people like to invent their own proof ofs. And they're not always proof of anything. But anyway, so they created the concept of proof of burn. And what they did is they told people, hey, if you've got this Dogecoin, go ahead and send it to this address that nobody has the private keys to, because the address is very specific and really complicated, and nobody's going to randomly pop across that address. Well, they ended up, users of Doge ended up burning 1.8 billion of the coins, which was a significant amount of the actual total coins that Doge had. If this had been a targeted attack, you can bring down a competing currency. They didn't bring down the currency, but I found it very interesting and wanted to include it as an example of a social hack. Name clash. Name clash is something that I actually saw last night executed. So I mentioned the meta currencies, the Bitcoin 2.0 currencies, and their goals are to create other currencies. So most of them will allow me to go on top of them and to create a currency called Bitcoin, and to create a currency called Doge Party. So I can do that on a couple of the platforms. Now we've got a real authentic coin that's traded amongst people, and now I've got a number of counterfeit tokens as well. So this is actually starting to happen, and people are finding that they're buying stuff that's not what they thought it was because of this name clash. There's a group that I'm familiar with called Name Claim, and they're trying to establish a standard similar to how domain names are acquired, and just a way of validating authenticity and claiming your name and locking it in across all the systems. But it's it's just a discussion at this point. So this is something that I've recently heard about within the past 2 months, and it's kind of big if it happens. Another one of the goals of the Bitcoin 2.0 I mentioned are smart contracts. Smart contracts are these small little pieces of an agreement that execute. They execute automatically. Once they're pushed out, there's nothing that can be done to undo them besides the network going away, unless we built in ways to undo the contract. What's come about because of that, out of that concept, are what they're calling DApps and DAOs. What that means DAO is a distributed autonomous organization. And there are countries now that you can create a legal entity, an organization, that has no board members, that has no owners, it is a company and it's not liable to, it doesn't answer to anybody. And what software developers are doing are they're building these blockchains and these contracts that will effectively control how these companies operate. So they're going to be a scripted company in order to say, like let's say you use Notary, for example. Say I want to get a document notarized. So I will send a copy of my document to this particular piece of code that's running somewhere. It costs Bitcoin or some other currency to run, so that's how it runs perpetually. Is it has a people pay it. It might pay its stockholders. It might, so the entity might pay its users back somehow if there's say profit sharing. It goes ahead and it does some work. It takes a digital copy of my document. It hashes it and it stores that hash in the blockchain. So now I've got my document notarized. It goes ahead and it destroys its reference to the document, and it just sits there and waits for somebody else. So that's a small example of what an autonomous program can do. An autonomous organization is, well, a company or a large group of these applications. Well, they're being written by software developers. They're being tested by the users, and they're being, or going to be given, millions, if not hundreds of millions of dollars. I think that that's dangerous. I have a hard time giving control to any software, let alone software that's not rigorously tested. The people that are working on the autonomous organizations and the distributed apps, the decentralized apps, they're innovative, but I don't think that they've caught on yet. That they need to really focus on the security and how this is going to, how they're going to keep things from going really wrong. So in the future, I suspect that we're going to see a couple of really big examples of an application that runs like this. So say a Napster that can't be taken down. And I also think that it's going to be exploited by somebody who looks at the source code and figures out a way to take advantage of that and get into everybody's computers and take everybody's money. So some of the things that can help mitigate this is testing. I'm a proponent of crowdsourcing testing because I work with this company, Crowdcurity, and they have a 24-hour-a-day security testing, group of people. They've always got new users looking at my site, looking at the source code, and it's good to have the constant eyes on them. But it's still, it's still pretty low-hanging fruit. It's just one tiny step above running an automated tool all the time. Some, obvious things are to not leave passwords and not leave AWS keys in your GitHub. Everything in the Bitcoin space is open source. Or just about everything. You're pretty much laughed out of the space if you haven't released your software onto GitHub for the scrutiny of everybody. They don't know what they're looking at when they want to see your software, but the users that want to spend the Bitcoin, they need to see your software. If you're a company that's dealing with other users' currency, don't store a whole bunch of money all in one place. Always update the software. These are all pretty standard things that anybody that is exercising good security should employ. Again, testing needs to be worked into this into the whole plan from the beginning, and it needs to continue to be tested, automated. And last is let the users control their key. So some of the problems that I've seen, some of the problems I've seen in the news are websites that control the user's private key. So for convenience, I want to go to this website and have this website be my wallet. And this wallet takes my private key and it stores it in a database. Maybe it's encrypted, maybe it's not. So that the website can sign my transactions whenever I log in and tell it I want to send Bitcoin someplace. Well, that's dangerous because when one of those sites gets attacked and their database falls down, that attacker has access to hundreds and hundreds of keys and can just go in and drain the funds from all those accounts. And this has happened to the cost of millions and millions of dollars. There's some pieces of software that I'm working on, and a concept that of the address canary. So if you're a website developer or application developer that's working with Bitcoin, sprinkling addresses around your source code or on the machine, sort of making a pseudo honeypot, but it's like tripwires. So if somebody does get into your system and they're in the FTP directory and they see something obvious and they go and they're like, oh wow, here's an address and it's got 0.2 Bitcoin in it. They're going to go ahead and snatch that and move on. Well, if the company has strategically placed those around, and monitor those addresses for activity, they'll know really quickly and can automate steps to close access and take action before the problem gets ridiculously large. So yeah, does anybody have any questions?
Do any of the coins have a plan to migrate to another algorithm when someday in the distant future the SHA-256 or whatever algorithm they're using is no longer sufficiently secured up?
Yeah. So that's happened a number of times, and they just update their mining clients to. They don't actually have to migrate anybody. They just have to have all of the users, or 51% of the users, upgrade to the new software that uses that new hashing algorithm. And then they're going to have to put in keep the old hashing algorithm in so that they can verify the transactions that currently exist in the blockchain.
So the addresses that we were talking about spreading around, would those be addresses within the hierarchical file structure, directory structure, or within the code?
Well, they would need to be placed to where they look like somebody found them. So you might have a database that's not password protected in a field in there called keys. Or you might have a data store. It's a folder full of JSON files. And inside those JSON files, there might be one particular field that's got user keys. So yeah, the idea is just to sprinkle them around different parts of your application, different potential entry points that might one day be exploited, and set those tripwires up. Anybody else? All right. Thanks, everybody.